Okay, hey, Das here. We're going to be doing a little more geometric unity thinking out loud. So I was making my way through the Oxford lectures, or the Oxford lecture so far, and I thought I understood something, and like the fourth time I was going through it taking notes, I was like, oh, I completely misunderstood what he was saying. My frame was out-framing his actual statement. And suddenly, I think this is an unlock for me with the what he was saying during the Dark Horse podcast conversation about how he had his glass rim and he wanted to talk about like the tangency to that circle, right? And how he wanted a rule to tell him how to measure at any point on that circle. And for the, like, he tries 3 or 4 times because Brett is, I think, just as confused as me. And he goes at it at great length, and I was like, man, he's clearly trying to communicate something, and I'm not clear on what. Right? Like I was if you look at my 3-hour, breakdown / notes version of the Dark Horse conversation, I'm sure I don't know how long I spent on it, but I spent a lot of time trying to figure out, like, is he talking about an algorithm that would determine for him the steps in which to take to measure lengths of tangency as compared to the points on the line, here, I have this up for a reason, right? Like, let's, and this will be familiar. Whoop. Like, if you're talking about, how do I measure these lines? How do I measure these lines? And I thought it had to do with, like, you're extruding extra dimensions from this, about, related to the paper towel core he'll talk about later, right? It's a tube. And what I think clicked for me during the Oxford lecture was that he basically talked about the same concept, but from an opposing perspective, at least the way I was formulating it. Maybe he's not, but the way he talks about it in the Dark Horse podcast is that he's trying to, here, let me erase this. He's trying to discuss the idea with Brett in the sense of, like, coming at it from a fresh slate. So he's like, imagine you have this circle. It's a one-dimensional line, right, that's been twisted onto itself. He doesn't quite describe it that way, but you understand, right? Like, a circle is just a line that connects itself at its end point. It's a little Ouroboros. So if you're on a line, all you need to know is where you are on the line. You only need like one unit of information, like, to describe where you would be on the line. So I can also just use one unit of information to describe where on this circle I am, right? He says angle. Like, just give me the angle, and I understand where on the circle you are. And it's like, okay, so we're just setting the table of, like, it's a one-dimensional unit of something that's like, I'm putting little end brackets, and like, that's the start, that's the end. And on the circle, it would be like they combined, they connect. So he's just, with Brett, he was trying to kind of have this thought experiment that starts with something simple, and then he'll build from there. In the Oxford lecture, I feel like he, at least partially, he's describing the same phenomena from a completely different perspective. Instead of starting with, the circle represents a metaphor for for proto space-time, for whatever, like, exists before you put a metric on it, right? That's what the circle, the rim of his kombucha glass, that was what it was intended to represent in the metaphor. In the Oxford lecture, he talks a bit more about, he sets the table still. He says he has a 4-dimensional manifold, right? He has boom, and he calls it X4. Whoop, and I'm still not clear exactly why he picks X4, but he does. And then, here, let's erase the circle. Boop, boop. So in the Oxford lecture, boom, he has a manifold that's X4. And then he says that he puts, boom, 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 these fibers, which I believe it's accurate to say later can completely be described as, it's a fiber bundle that has some relationship to this base space. And these fibers, boom, are very specifically, and if you know that I'm wrong about this, please hit me in the comments or hit me with a video or whatever, because I'm just trying to figure this out. So if you know that I've got this wrong, please say so. But it appears that these fibers, very literally and mathematically, represent the space of all possible metrics for this x4 manifold. So it's kind of like a way for me to think about it, at least at first. If this isn't mathematically accurate, I don't know, but it's like you're positing a possibility space based on your initial state here, based on your initial situation with x4. You have, and this part I'm pretty sure I'm misunderstanding a little, but whatever, we'll see. The idea is you have length 4, right? So 4 directions, and you somehow have relationships between those 4, which should be angles, right? So if he's talking about rulers and protractors, that's just lengths, rulers, and protractors are angles. So you have 4 plus 6, that's 10. And then I'm still making my way through the Oxford lecture to understand how he got to 14. At the end supplemental notes with his little PowerPoint, he gives an equation that, going through the equation, I'm still like, I don't know how you got this math equation, like where it's coming from. Why is 14 decided? Because through the math equation, he ends up with 14, which, if you've seen the Oxford lecture, he talks about like a fiber bundle here, and then basically there's like the horizontal bundle is what he calls it, this guy here, which I think a way to describe it would be like you're projecting the base space up into the fiber bundle. I don't know why it's important that it's not down here still, and instead it's up there, but it seems important. And in the space of the 10-dimensional fibers, you put this horizontal space, that gives you 4 more lengths amidst the 4 plus, well, that's not a plus, that's plus 6 angles equals 10. So if you do that plus 4 more because you involve this horizontal bundle, then boom, that would seem to equal 14, but I feel like I'm completely misunderstanding his math here. I'm drawing on my tablet. Well, that's the pen. So the math that I found in the PowerPoint at the end did not seem to describe that. It didn't seem, at least, to be a mathematical description of, fibers made out of 4 plus 6 angles equals 10 for fibers, plus another 4 represented by a projected base space into those fibers, therefore 14. It didn't seem to be describing that. Now, I could be wrong. It seemed to be, what was it? It was, am I going to try to do this from memory? It was like xd plus 3, d over 2 for some reason. So x, right? It was kind of like that. I think I'm messing up the math here, but it was intended to be 4. I think that's what it was. The in this conception in the PowerPoint, let me bring that back. It was x to the d. So it wasn't 4. He was setting up a variable that you could fill with anything. So, but if d equals 4, then it becomes x4, and it becomes 3 times 4. So then 4 times 4, this becomes 16. 4 times 3, that's 12. 16 plus 12 is 28, I think, divided by 2 equals 14. So that was the math that seemed to describe the metric, or the space of all possible metrics on a base space, which he calls x to the d, but he wants it, or seems to describe it as x, as d equals 4. So it's really x4 becomes 14 when you do all of this math here. So I don't know how that math describes that. So to go back to the beginning, because this is really the point of this video, is to describe what I figured out. So he had a base space of 4 in the Oxford lecture. He says he has a base space and he calls it x4. And then let's clean that up. And then he says that he has, how to talk about this metaphorically. I'm going to go with what I understood metaphorically. And again, please chime in if you know that I'm completely off base. I would really appreciate it. I'm just trying to figure this out. So the fiber bundles, it's kind of like this here. The base space is a 2-dimensional plane, right? It has that dimension. It has that dimension. It's only got like x, y in traditional coordinate systems, right? And then you're going to posit something that is the possibility space of all possible metrics that you could have on this base space. And at least metaphorically, you're going to depict that possibility space as like this direction, the z direction, which is sort of almost foreign to the xy plane of the two-dimensional base space, right? Like it's like this other thing that's tangent to the base space. It's like this numinous realm where all things are possible or possible. So that's why you're going up instead of like across or that way. So we're going to go up in the z category, or in the z coordinate system in a traditional setup. So these fibers, I don't understand how that works exactly, but at least metaphorically, these fibers are intended to represent all possible metrics that could be utilized on the base space. So if that's the case, then, and this is the key point that for me during the Oxford lecture was like, oh my God, he's describing the dark horse thing in a different way, is during the Oxford lecture, he says that if you pick a point on one of these fibers, which that's just one of the fibers, and you'll see, I'm going to cut in the dark horse, just the tiny moment where he talks about like trying to, I need a rule to measure any length tangent to the circle. I want to know how to measure any length, any way, and use a different ruler at every point. Like I'm going to cut in that part, and I'm going to cut in the lecture at Oxford part, just the piece that talks about this points on fiber bundles. So on the fiber bundle, any point you pick, and at first I thought he was saying that if you pick a point on the fiber bundle, then it sort of like projects down onto the base space. So if you were to pick like a point here, then it shadows down to here, and a point here shadows down to here. And so like maybe that's like a line. You could, and if you picked a few back here, then you could boop, 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 and then like, ooh, it's a shape that you've, some sort of weird geometric shape that's, governed by these very different places on the fiber bundle, right? But that's not what he was saying at all. What he was really saying is, oh, that's a lot of marks. Let's get rid of all of these things. I promise you it's quicker to do this than erase. Or is it? So what he was really saying is you pick a point on one of these fibers, and that point determines the metric for the base space. So if I pick this point here, that determines a specific metric down here in the base space. And if I pick this metric here, if I pick this point here, that determines a different metric on the base space. And this point here determines a different metric on this base space. So, and it makes sense, right? Because the fibers themselves are intended to represent sort of it's a spatial metaphor for the space of all possible metrics. So of course, an individual place in that space is one particular metric. And this is a different particular metric. And this is a different particular metric. So you're deciding, I don't know if this makes sense, but like it's almost like each one of these points projects down a particular metric. So when he talks about things like, imagine your tongue and, sweet, salty, bitter, umami, etc. Those tastes are particular metrics, but your tongue doesn't inherently have a metric for measuring like amount of sweetness, amount of saltiness. Instead, it just has receptors that respond to particular things, right? But if you were to decide on a particular metric, like I'm going to decide on salty and like, let's say this much electrical response in the nerves of the taste buds of the tongue, I'm going to call that 1 unit of saltiness, and because it just linearly increases, like that same extra amount means 2 and the same extra amount means 3, like it's not logarithmic, or like it doesn't get like fall off as things get sweeter, like sweeter and sweeter and sweeter. It doesn't, or saltier, saltier. There's no like cross off point. I don't know, that it's complicated by the organics, right? Like I'm sure our tongue does have some sort of overload point where putting more salt really doesn't mean the increase amount of sensation of salt, because there's probably software at work there, right? To kind of tune our responsivity in a certain golden zone of mattering to our biology. Anyway, so in the Oxford lecture, he's starting to talk, or he's talking about these fibers pick a point and it determines the metric for the whole base space. But if you pick a different point, it determines the metric for the whole base space. This is what he was trying to say. except he was trying to describe the base space first and then suggest what the fiber bundles are up to and what picking a particular point on a fiber bundle would do, but without saying fiber bundle and without saying pick a point there and it determines a metric. Like, instead, he was trying to keep his metaphor to just, you know, this circle glass rim and like, how do I measure wherever I please, however I please. But in the Oxford lecture, he's definitely talking about imagine the space of all possibilities. And if we pick a point here, it determines a metric. Now, I'm still working through it to really understand the repercussions of that, but it does seem to be something that helps his, I'll say argument about, like, don't do, like, what Einstein did basically is pick one place, not even necessarily using this concept of all possible metrics and a fiber bundle, but you end up in the same result. Even if he didn't get to this that way, he picked a particular metric, which there could be a place on the fiber bundles to pick this same metric, right? Einstein picked a metric that determined the metric for the entire base space, and then he stayed there, and he's played in that box, that sandbox, ever since. And he hasn't gone outside. And all of his physics equations occur here within this very particular metric. And one of the cornerstones of geometric unity and Eric's argument here is that, like, that you shouldn't be doing that. That this space, this bundle, and the horizontal bundle that somehow makes sense up here, this chimeric bundle made up of the horizontal bundle here and of these vertical fibers here, that bundle, he's saying those two together, the chimeric bundle, is really where you should be playing with physics, and really where the equations for the fundamental forces and connections and matter and the area, the arena rather, the general relativity, etc., that all of that should be happening in this space. And then you can do things to derive specific stuff on the base space. Because it appears, and again, tell me if I'm wrong here, if anybody knows, that we live down here on the... That's a terrible... I guess that guy's running. Ah! Here's my beer! A little run cloud. That we live down here, that this is our... Or, see, I'm not clear on that either. Is it that human beings, like, our experiencing of reality, does that occur on the base space of X4? Because that was the proto-space-time. Or do we, like, experience reality up here on the possibly a projection of X4 into the vertical fiber bundle, but as a horizontal bundle? Like, are we up here? Are we up here holding our beers? I'm gonna keep it in this joke. Or is it something else entirely? Like, I'm a little unclear. Are we witnessing our experience of reality from here, or like here, which would be a combination of the vertical bundle and the horizontal bundle? Unclear. And that might be, partly just my misunderstanding of the theory so far. Who knows? Maybe it'll become clear later. But yeah, so every time he was talking in the Dark Horse conversation about, look at my glass rim, how do I measure all these, tangent lines along, or tangent to the rim itself, and how do I measure them any way I please, with any metric I please, what he's really saying in a different form is, imagine this base space is analogous to this glass rim, and imagine you had a possibility space of all possible metrics, all possible ways to measure all possible lengths. That's what these lines represent. And then when you pick one, you're picking a particular metric, and then you're saying, okay, I'm going to use that metric on this base space. So in the glass thing, you would just kind of like sit here and... why is he frowning? I was trying to make him think. There we go, he's thinking. But he's having a hard time with it. Hey, everybody. He's just going to think to himself a particular, I don't know, how would you visualize a metric in his head? But, that's a XYZ. He goes, oh, I'm going to use this metric. Haha. And he's just going to apply it to the glass rim. And then maybe this guy over here is like, no, I am going to, jeez. Aha, hello. I have an idea represented by a light. That's a terrible looking light bulb. We're going fast, you understand. I'm going to use this instead. So like, you know, maybe this guy wants to use kilometers for some reason, and this guy wants to use, you know, imperial feet from forever ago, you know? And this chick over here wants to use, you know, I want to measure it in units of standardized snails. You know, who cares? It's gauge theory, right? You're just using a metric and then just stay constant with the metric. And as long as that particular metric you're using is translatable into other metrics, and it doesn't really care. It doesn't really matter what you use. As long as standardized snail units can be translated into metric or into imperial feet, like, then who cares? It doesn't matter what the initial discussion of units was. So, to sum up, in the conversation in Dark Horse, he used the rim of a glass and said, how do I measure the tangent line to any point on this circle? And how do I determine or measure those lengths? How do I measure them in any way, with any metric, and any possibility, at any time? And the reason that was confusing for me is that he wasn't describing the rest of the metaphor. And in the Oxford lecture, he talks about a base space of x4. God, I just can't connect those fours. And then from that base space, you derive, well, the space of all possibilities of what metrics and what measuring devices and how. That's going to be represented by these fibers coming off the base space into another realm. And if we pick a point here on those fibers, we determine a particular metric. If we pick a different spot on the fiber, we determine a particular other metric. That's the same way of saying the same thing. That was the unlock for me, is he's describing the same thing two different ways. I hope this is useful. It's funny because I don't know that it's like a bunch of new information, but for me it was useful. I feel like there's another piece here. I guess the difference for me is that in this description, he's basically giving a reason that the metric could be different, or a process for determining its difference, you know? Like you picked a different point on the possibility space. And therefore, of course, it's a different metric. Whereas on the glass rim, it was like, well, why do you want to measure, like, there's an infinite number of points along this rim, and why do you want to be able to measure the tangent line in like a bajillion different possible ways? Like, what purpose does that serve? And what purpose that serves is that the physics in geometric unity will be done in that possibility space. Is that you need to be able to determine how to measure a tangent line, no matter, like, in any way possible, in any way you feel like, because that's the only place physics happens. And then there's some sort of sampling that happens that projects it, I don't know, back down into X4, into the base space, or projects it into, project might be the wrong word, but, you know, puts it into this horizontal bundle maybe. Wherever we live, hanging out, that's right, holding the beer. It's explosive, apparently. Oh no! Gets very happy, I guess. I don't know. So that was the piece. It gives me like something to hang my hat on as to why you would care to measure things in different ways, in different measures, in different lengths, in different ways with custom rulers. What did that mean? It meant he needs to have the flexibility of determining a different metric for a different unit in a different space, in a different length, in a different time, no matter the thing, no matter the where. Like, he needs that flexibility because that's where the physics happen in GU. The physics are determined in the possibility space of what in the Oxford lecture he called U14, and then in the PowerPoint afterward, I think he calls it now Y. And I think it'd be Y14. So not the base space, but the thing that emerges from the base space. The base space gives birth to this possibility space, which somehow equals a dimensional aspect of 14, and then somehow that is, I think, condensed down to what we experience as 3 dimensions of space and 1 dimension of time. So I don't know if that's a coincidence that the base space of X4 is 4, or if it does have an intrinsic connective property to we experience reality as 3 dimensions of space, 1 of time. That's 4 dimensions. Is it important that the base space he describes as X4 because we live in a seeming X4 reality? Or no, that's just what he took as the base space for who knows why, and then it gives birth to 14 dimensions, and then it's condensed down again to our experienced reality of 3/1. 3 of space, 1 of time. Anyway, so yeah. The probability space is where he needs to be able to do the physics. That's why it's important, and that's why, in the Dark Horse podcast conversation, he tried at length to describe why he needs to use custom rulers at any point on that circle, measuring the tangent in any way, any time, any length, any metric, any units. Why? Because that's the space that physics happen. And in the Oxford lecture, it's a little clearer. So, yeah. I hope this was useful to you. If it was, please feel free to say so in the comments. I would appreciate it. It's cool to know other people care about this material. And if you, more importantly maybe, if you have more insight than I have, which is probably true, then feel free to jump in, and I would love any clarification from anybody who understands this deeper than I do. Again, not being a physics or math expert, this is interesting wading through the waters of math and physics. So, yeah, I'm going to keep trudging my way through the Oxford lecture. I will be probably making videos about that soon. Well, I don't know about soon, because I thought this would take, like, it's a three-ish hour video, and some days when I sit down to do it, I will spend, like, a lot of time, and I got through 10 minutes maybe of the material as far as the lecture's progression goes. So, we'll see, because I would like things to be clear for me before I really put them into video format, especially if I'm going to attempt to rephrase things my own way. But we'll see. So, but forthcoming, sometime soon, hopefully sooner rather than later. If you're into this, feel free to comment, please. And I hope more people dive into it in a similar way. I would love to watch other people talk about this too. See you next time.
But we could do the whole thing visually. So for example, for those people who are watching this rather than listening to this, I'm now holding my glass of recently drained kombucha, and the rim of it seems to be close to a circle. Now, if space-time were just one circular dimension,
yep,
then I would claim that the enlarged structure, so in my theory, 4 becomes 14. The one dimension, that is the one parameter, people will think a circle is 2-dimension. Again, it lives in 2 dimensions,
yep,
but because there's only 1 degree.
You only need one number to say where you are in the circle.
Just give me the angle.
Yeah.
Right? That circle would generate something of the 1 original dimension plus 1 dimension, which for me would be a way to measure length at every point on the circle. So a different ruler to measure lengths.
For every point in the fibers, we get a metric downstairs on the base space.
So wait, I don't get this yet. There are an infinite number of points around that circle,
yep,
right? The circle is infinitely divisible. You're saying you want a different ruler for each, so as finally as I divide, you want a different ruler for each point?
I want a rule that tells me how to measure length.
A metric
on the line tangent to that circle at any given point.
Every point in the fibers, we get a metric downstairs on the base space. We get a metric downstairs on the base space.
Okay, so wait. There are an infinite number of tangents to the circle. And
yep,
you want to measure how much of a line segment you have. You want a ruler that allows you
I want an infinite line at every point,
okay, good,
tangent to that circle.
Yeah.
And then I want a different ruler, a rule
point in the fibers, we get a metric
that tells me how I can measure distance along that line where it doesn't have to all come from one ruler that I place at every point. Imagine that your proto-space-time was like an infinitely thin hairband. If you started off with an infinitely thin hairband, then for every point on that hairband, imagine the space of all possible things that you might call of unit length, all possible rulers.
Okay.
And allow that a ruler can be either marked with positive numbers or negative numbers for whatever reason.
Yep.
What I would claim is that the object that I would create, if I did the same thing, which I'm doing to 4 dimensions, turning it into 14, would turn the hairband into 2 toilet paper cores going lengthwise down the tube, is every possible ruler with the same sign. So the reason you have two
is because there's a positive and a negative.
there's a positive and a negative. That's why you have two. So effectively, you took a long tube, you cut the middle part of the tube out. Okay, so in this case, for example, that simple hairband generates a paper towel core that falls into two pieces. Turning that into the analog of space-time is wrapping that hairband in some way around the towel core so that it goes around once.
Wait. You've lost me. The towel core, I thought,
Is
was
the
the
space
extension
of all rulers that could go at any point. So just move the bit of the hairband up
So
to the...
if you put the hairband on the towel
Right.
roll, then you could mark every space, and then you could move it up and down, and that would tell you which rulers.
And you could
were
move
using.
it up over here and down over there, so it's got a big ruler at this point,
okay.
and a small...
Cool.
But the idea is that each point on the hairband only goes through one ruler, which is represented as the space of possible rulers.
Each point on the band intersects exactly one point on the tube.
1 point of the longitudinal lines on the tube. Every point in the hairband only goes through one line along the lengthwise direction of the tube.
Yeah.
Okay?
Got it.
So that's a choice of a particular ruler. The line along that tube is the choice of all possible rulers.
Okay.
Okay? Now imagine that you had physics that was happening not on the hairband, but on the tube. And which, like, you could ask for the temperature gradient across the tube. Maybe part of the tube is warm, part of the tube is cold. And the only thing you're going to record is what the temperature was like at that point that the hairband was around the tube.
Yep.
That is effectively the new use of the space-time metric. We knew about rulers, and we knew about protractors, but we don't have a model in which that is a periscope, importing information from the tube back to the hairband. In my case, what I would say is that the hairband has enough data to build the tube, which is, tell me about the space of all rulers I could have at every point on the hairband, measuring the tangent directions. Then, on the hairband, now that the hairband has generated the paper towel core, now I do physics on the paper towel core, like it can have fields, effectively, stuff that roam around on the towel core that are natural for the towel core. And I say, well, can I perceive all of that? No, you can only perceive the part that's along the hairband.
So,
and then the idea is that we're fooled, in my story, into thinking that the physics is all happening along the hairband, which is, in our case, the four-dimensional world. But the physics is actually weirdly happening on this 14-dimensional auxiliary structure, which is the analog of the toilet paper or the paper towel core. And we're only sampling the part through the periscope of putting the hairband around at one particular latitude across those lines of longitude.
It turns out that if this is x4, and this is this particular endogenous choice of U14, we have a 10-dimensional metric along the fibers. So we have a G10 mu nu. Further, for every point in the fibers, we get a metric downstairs on the base space. So if we pull back the cotangent bundle, we get a metric G4 mu nu on pi star of the cotangent bundle of x. We now define the chimeric bundle, right? And the chimeric bundle is this direct sum of the vertical tangent bundle along the fibers with the pullback, which we're going to call the horizontal bundle, from the base space. And the great thing about the chimeric bundle is that it has an a priori metric. It's got a metric on the 4, metric on the 10, and we can always decide that the two of them are naturally perpendicular to each other. Furthermore, it is almost canonically isomorphic to the tangent bundle or the cotangent bundle, because we either have 4 out of 14 or 10 out of 14 dimensions on the nose. So the question is, what are we missing? What are we missing?